Hi, hopefully this is recording. What this tutorial is going to be about is just how to actually calculate the standard error of the mean, and also to show why it's important to calculate the standard error of the mean. Oops, I'm just going to copy this over here. Okay, so we've got here some data. Let's talk about what this data could be. We've got two different groups here, so let's say that these are quiz scores, and these are for students who are homeschooled, and these are for students who go to public school. And we'll make this the same. Just widen that a bit. Terrific. Okay, so as you can see here, we've already calculated the averages for all of these different students, and now we would like to calculate what the standard error of the mean is for each of these different conditions. So how do we calculate standard error of the mean? That's a really good question. Conceptually, how we'd calculate standard error of the mean is we'd first of all take the standard deviation, and then we would, of course, divide that by the square root of the total number of scores. So this is what we would like to do in order to calculate the standard error of the mean. How do we put this into Excel so that the computer can understand that we'd like to do this and make the calculation for us automatically? Good question. So we're going to use equals, and come on. I'm going to go to our formula user. Here we go. So the one we want, in this case, because each of these are samples, they aren't the entire population of homeschooled or public school students, we're going to use sample standard deviation, and we'll select all of these scores. Be sure not to include the average, and then we're going to divide it by the total number of scores. So how we can do that is we can go divide by, and then we can just use a count function. Nope. First of all, sorry, we're going to divide by the square root of, and then we're just going to count the total number of scores in this area. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 scores total, but we don't actually have to count it all out by hand, and this is really easy if we've got large columns of data where it's a pain in the butt to count everything. So we'll just close off the brackets, and that's what the formula for this is going to look in completion. And we've gotten a standard error of the mean of about 0.359. So this is giving us an indication of how much the mean value itself is likely to vary. It's slightly different from standard deviation, which gives you more an indication of how each individual score is likely to vary within the sample. We'll do a shortcut. We can actually just click and drag this over into the next cell, and it automatically calculates the standard error of the mean for that set of scores as well. And we can do this for the other two over here. And this is just some syntax error, so we'll delete that. We'll delete that as well. Fantastic. So now we have our calculated standard error of the mean for all these different conditions. So let's graph this out and see how it actually affects what we're looking at. So one possibility is that we could be looking at quiz scores for this whole section here. So let's just highlight this by boxing it all around. So we'll make a graph, go insert chart, we'll make this a clustered column graph. Here we go. We'll select our data. So we're going to add our averages. Fantastic. We'll call this make our labels. There we go. Oh no, that's not quite right. Let's fix this. No, we don't want this. So we just want one series. We would like the y values to be the two different averages. Why is it doing that? There we go. And we'll let the category X labels be homeschooled and public schooled. There we go. So now we can see in this set of data, the students who are homeschooled have a lower average than the students who are public schooled. We can just delete this, and what we'll do now is we'll just add a few more formatting details to our chart so we can make sure that we know what we're actually looking at. So here, for the horizontal axis, we'll say this is education setting. So a good way of summing up whether they're homeschooled or public schooled. For the vertical axis title, we'll do a rotated axis. We'll make these average quiz scores. Let's say this quiz is going to be out of 18. And finally, we'd like to give a overall title to our graph, so we'll call this quiz scores for homeschool versus public school students. Terrific. Now, let's add our standard errors of the mean in the form of error bars so we can have a more detailed look at this data. For this, we're going to go to the chart layout, go to error bars, go to the error bar options. So for this one, let's say we want error bars in both directions. We're going to select a custom error bar, specify the value, and then we're just going to, for the positive error bars, select the two standard errors of the mean we calculated for these two groups. We'll do the same thing for the negative error bars because we want these two error bars to be the same. And there, you can see that we have, for the homeschooled, a slightly larger standard error of the mean, and this corresponds with a wider error bar. For the public school students, we have a slightly narrower standard error of the mean. So what's this telling us? Well, we can see that since, excuse me, these error bars are quite wide and they're very close to overlapping, even though we do see these differences between these two different educational settings, the fact that there is so much variation in these two scores means that it's less likely that these differences are going to be significant. Is it going to tell you outright whether it's significant? If the two standard errors of the mean are overlapping, we know for sure that they aren't. If they are not, if they are non-overlapping, we won't be sure if these differences are significant or not, and we'll have to run a significance test to be sure of that. So in a different situation, though, we could have very similar average scores. So let's make a chart for our second school. Just try and breeze through this as quick as I can. So charts, column, cluster graph, select data. We're going to add one series. We'll let our y values be equal to, come on, oh, for goodness sakes. We're just going to have to move this over so we can actually access the data. Come on. Here we go. So we'll try that again. Select the data. We'll add the y values. We'll let those be these two averages. Make the category X labels the same, so homeschool and public school. And of course we didn't add it, so get it right this try. There we go. Here we go. Okay. So we've got homeschool and public school students, and as you can see, the overall averages are very similar to what we have in the previous chart. I'm not going to worry about adding these two labels. Know that they should be there, but let's just skip directly to adding the error bars. So we're going to chart layout. We will go to the error bars, and we'll go to the error bar options. We would like to use error bars in both directions with caps, and we're going to make them custom. We're going to specify their value to be, oh no, do I have to move this again? Excel can be such a pain sometimes. So now we should be able to access our error bars, go to options, specify the value. Here we go. So we'll make our positive error bars, these two calculated values, and we're also going to make our negative error bars, these two calculated values. Okay. So what we're going to see right here is that even though the overall averages for these two groups are very similar, in this first situation, because there's quite a large standard error of the mean, there's quite a lot of overlap between these error bars, whereas in the second situation there's less overlap between these error bars. What this is telling us is that even though the average difference between these two scores for homeschooled versus public school students is about the same, the overall amount of variation within these scores is quite a lot smaller in the second situation, which makes it easier to draw different inferences about whether these average differences are significant. So I hope that from this you can see that not only is adding standard error of the mean to your graph something that is quite nice to look at, but it's also giving you some important extra information when it comes to interpreting the results from a graph. So I hope you'll include it in your graphs, especially if you are hoping to receive points for that on a lab assignment. That's all.